Welcome back to my YouTube channel. In today's video lesson, I'll be discussing about a very important aspect in chemistry, and it is simply called atom. Now, this video lesson is specifically made for students, science students to be precise, in their first year in any university, be it the University of Benin, the University of Lagos, University of Ibadan, and other universities. And also, this video lesson is important for students preparing to write the JAMB examination, that's the UTME examination, and also the post-UTME examination. Now, let's get into this video lesson. So the first thing we have to take note here is what an atom is. Now, it must be noted here that atom is simply the smallest particle of an element that can take part in a chemical reaction. So the basic unit of an element is called the atom, like the basic unit of life, which is called cell. So we have to take note of some important concepts of this atom, because an atom is made up of three important subatomic particles. So all these subatomic particles makes up this atom. And what are these subatomic particles? I call them pen. Okay, I call them pen, which is P-E-N. So all of these are the subatomic particles, whereby P here means protons. So this first subatomic particle, which are found in an atom, the first one is called proton, while the E here means electrons, and lastly, N here means neutrons. So all these are the subatomic particles, and these subatomic particles, they have their respective charges. Like for the proton, it is, or they are positively charged. Electrons are negatively charged, and lastly, neutrons are neutral. So this is something we must take note of. So moving further, let us discuss about their discoverers. So who discovered this subatomic particle? Because we have various scientists that discovered this subatomic particle. So we'll be discussing about them. So their discoveries. Okay, their discoveries. So for the first, which is proton, it was discovered by a man called Lord Ernest Rutherford. Okay, Lord Ernest Rutherford. So this is the scientist that discovered the proton as a subatomic particle. So for electrons, it was discovered by a man called J.J. Thomson. And lastly, for neutrons, it was discovered by a man called James Chadwick. And all of these are subatomic particles which are found inside an atom. And remember, the smallest unit of an element is called the atom, as the smallest unit of life is called the cell. The smallest unit of the kidney is called the nephron. So this atom basically now is the smallest unit of an element. Okay, we have various elements in the periodic table. So the point here is this: all of these subatomic particles, they were discovered differently by various scientists and also in different years. So let's talk about the years that these subatomic particles were discovered. For proton was discovered in the year 1917, whereby for electrons, it was discovered in the year 1897, and lastly, for neutron, it was discovered in the year 1932. So if you observe, which of these subatomic particles was first to be discovered? It was electrons. So electrons, basically, they are the first subatomic particles, and they are negatively charged, and it was done by this man called J.J. Thomson. So all these must be noted. Now, next one to talk about is their location, because these subatomic particles, they are found inside the atom. Where specifically? I cannot just say they are found inside the atom. We have to be specific of where they are found. So let's talk about this aspect, their location. And before we talk about that, we have to draw the diagram of an atom. So let's say this is an atom. Okay, this is an atom. And an atom is made up of a centrally located structure. And that structure that is centrally located, it is called the nucleus. So let's assume this to be called an atom. And we have something that revolve around this atom. Okay, we have something that revolve around this atom, which I'm drawing now. So this is an atom. And remember, what did I say? I said that there is a structure in an atom that is centrally located, and it is simply called the nucleus. This must be noted. Now, this nucleus entails or contains two important subatomic particles out of the three mentioned. And what are they? They are protons and neutrons. So we have two important subatomic particles found inside the nucleus of an atom. And what are they? Protons and neutrons. So inside this place we're having the nucleus, we have two important subparticles, which are protons and neutrons, whereby the last basically revolve around the atom or the orbit, and they are called electrons. So you can see how all this works. So specifically, where is the location of the proton as a subatomic particle? It is found inside the nucleus. Where is the location of the neutron? It is found also inside the nucleus. But where is electron found? They are found in orbits. Do you get? So this must be noted. I'm about writing now. A region in space where there is a high possibility of finding an electron. Let's take this to be a space now. A region in space where there is a high possibility of finding an electron is simply called orbital. So if you observe for orbital, there is a what? There is a high possibility of finding an electron. But a region in space where there is a low possibility of finding an electron is simply called nodal plane. Okay? And lastly, a region in space where there is no possibility at all of finding an electron is simply called forbidden state. So you can see how all this works. Okay, they are very important. These are some important terms or concepts to take note on the introductory aspects to the atom. Now, if you are just joining this community and you haven't subscribed yet to this channel, do well to click the subscribe button to this video lesson and also share these lessons with your friends. So let's get into a very important aspect in this video lesson, which is determining the numbers of protons, electrons, and neutrons found in an atom. Now, since this is an atom, and we've already seen that this is the nucleus. So what type of nucleus is this? Is this a cell nucleus or an atomic nucleus? It is an atomic nucleus, not a cell nucleus. This is not a cell. This is just an atom. Okay, so if we are talking about, if we're in a biology class lesson, I'm going to call that particular, because cells are made up of various components, and one of them is the nucleus. So the nucleus of a cell, I'll call it what? Cell nucleus. And it must be noted here that this atomic nucleus was discovered by a scientist, and it is called Lord Ernest Rutherford. And also the nucleus is positively charged. Why is the nucleus positively charged? It is positively charged because it contains a positive subatomic particle called proton. So you can see how all this works. So let's get into the other part of this video lesson B, which is determining the numbers of protons, electrons, and neutrons found in an atom. Okay guys, let's get into one of the most important parts of this video lesson, which is how to determine the numbers of protons, electrons, and neutrons of an atom. It is very easy. Now, these two representations written on the board, both of them, they are called atoms. But now, one of them is neutral and the other is charged. So one of the atoms, one is neutral and the other is charged, because we have to take note of this. So one is a neutral atom and the other is a charged atom, because this is very important. It's going to help us in determining the numbers of protons, electrons, and neutrons found in these atoms. And we'll be solving questions on these cases. This is for case number 1, and this is for case number 2. So how do we solve questions of this sort? So you can see here that this particular atom does not have a charge, but this one has a charge, and the charge can be either positive or negative. So a charged atom, from our basic knowledge of chemistry, a charged atom, what's it called? It is called an ion. So this can be also regarded to called an ion, whereby this is just an atom that is without a charge, so it is neutral. So how do we do that? Before we even know how to determine the numbers of protons, electrons, and neutrons, we have to know what all of this representation mean. So the first is A. What does A signify? A here can be called atomic mass. And if I don't call it atomic mass, I can simply call it mass number. And lastly, if I don't call it mass number, I can call it nucleon number. Please, I did not say neutron number. It is called nucleon number. And lastly, for this symbol that is Z, what's it called? It is simply called atomic number. Or if I don't call it atomic number, I can simply call it proton number. So the point here is this. AZ, these are their representation. This is what it means. And it's still applicable to this other A and Z in this atom. What differentiates both of them is just how we'll solve the protons, electrons, and neutron number for these atoms. So make sure you watch this video lesson till the end so that you can be able to understand perfectly how all this works. So first thing I want to do here is to start with this first case, which is for which atom? We already know that this atom is a neutral atom. So how do we get the PEN for this atom? Very easy. Now this must be noted. It must be noted first of all that for we to get our proton number is same as this value that is Z. Do you get? The proton number is same as what? Z, because we already said that Z is what? Atomic number or proton number. So proton number is same as Z. So whatever number that will be here when we start solving practice questions should be our proton number. So if here was 11, what becomes here 11? Now moving further to get our electron number, how do we do that? It must be noted here that for a neutral atom as this, for a neutral atom, proton number is equal to electron number. For a neutral atom, proton number is equal to what? Electron number. So since proton number is Z, and we already seen that proton number, electron number, they equal. So what becomes our electron number? Same value that will be for our proton number. Very easy. So moving further to N, how do we get N? Very easy. Is by simply saying mass number, which is symbolized as A minus atomic number. I believe you already know that mass number can also be called atomic mass or nucleon number, because this is going to help us. This particular statement is going to help us to solve practice questions as we progress in this class lesson. So N becomes, what's the mass number? Mass number is symbolized as A, and what's the symbol for the atomic number? Z. So this is how we'll get our neutron number, and this is how we get our proton, electron, and neutron number for a neutral atom. And it's still almost the same for a charged atom, just slight difference. Okay, so let's go into this before we start solving practice questions. So guys, how do we solve the proton number for a charged atom? It can be positive or negative. Remember, when an atom has a positive charge, what will I call it? I will call it a cation. When an atom, okay, has a negative charge, I will call it an anion. Okay, and we have various examples of atoms that have positive charge, majorly metals, and for non-metals they have negative charge. But we have some group of compounds compounds that have both positive and negative charges. They are called Zwitter ions. And a good example is seen in amino acid. Remember, amino acids are the monomer unit of proteins. Okay, proteins are macromolecules. Okay, alongside carbohydrates and lipids, also regarded to be called fat and oil. So moving further, how do we get our proton number? It's still by same method. Our proton number is same as Z. And how do we get our electron number? Now varies. Do you get? For a charged atom, proton number is not equal to electron number. Okay, it's not equal, so I cannot just say electron number will not be equal to proton number and proton number equal to the Z we said initially. I can't do that, so I will then just leave this part, okay, and move over to the neutron number determination. And how do we get our neutron number? By same, which is A minus Z. It doesn't change. But how do we get our electron number? This is where we have to be very smart, okay, and know how it works. So how do we get electron number? It is gotten by using this formula, which is proton number minus charge. Proton number, which we already know to be Z, whatever value that's here, that's how we get our minus the charge of the atom. That's how we get our electron number. So with all this said, let's take examples. So let's work with the first example, which is example 1. Okay, example 1, let's say this is sodium Na2311 and it is without a charge, it is neutral. So I will use this case method to solve it. So PEN, so what becomes our proton number? Remember I said proton number is a value that is always down. It is 11. Electron number is what? Electron number for a neutral atom is same as proton number, so electron number becomes 11. Yeah, we've said all of these before, okay? And for neutron number, it is solved by saying atomic mass or mass number minus atomic number, which is A minus Z. So the point here is this: the value that is up is my mass number, the value that is down is my atomic number or proton number. So what becomes the value of 23 minus 11? That's what? 12. So you can see how all this works. So with all this said, let's go over to solve another example, which is example 2. But in this case, sodium now had a charge. Sodium now had what? A charge. So how do we solve questions of this sort? And it's what charge to be precise? +1 charge. So we then write proton, electron, neutron. So what do we do? So remember, proton number is always same as the value down here, which is 11. And electron number we can't solve now. Let's solve for this first. And we already know it's A minus Z. Neutron number becomes, what's our A? 23 minus 11. So this becomes 12. But remember, this is for a charged atom case. And to be precise, it's a positively charged atom. So we use our formula, which is proton number minus charge. What's the proton number? It is 11 minus our charge. The charge, you put it in a bracket. So in mathematics, minus times plus. Minus times, bracket means times, plus will give us minus. So 11, these are minus times plus is what? Minus. So what becomes our answer for electron? 10. So the PEN for this atom is 11, 10, 12 respectively. So you can see how questions of this sort are being solved without stress. So let's quickly walk through another example. But I think you solve for me and provide the answer in the comment section. You solve for these are aluminum Al3 plus, and these 27 and these 13. And you solve for these neutral form of aluminum. So you do this and provide the answer in the comment section. Meanwhile, let's quickly go over to other cases like chlorine 3517, chlorine -1, 3517. So let's solve for this PEN. So what becomes our proton number? Proton number is always the value down, which is 17. Since it's a neutral atom, proton number equals electron number, as earlier said, and neutron number is solved by saying A minus Z, which is A minus Z. Neutron becomes 35 minus 17. Neutron becomes 18. Very easy. But how do we solve this question? It's still very easy, but just that it has a charge. Now, in this case, it is a negative charge. So what do we do? Very easy. First one to do first is to get our proton number, which we already know doesn't change. It is what? 17. Is electron number 17? No, it can't be. So we hold on because we have a charge. So we already know A minus Z, which is 35 minus 17. That is that's 18. So how do we get our electron number? Remember, proton number minus charge. What's our proton number? Our proton number is what? 17 minus the charge. And what's the charge? -1. Mathematics minus times minus, that is plus. So minus times minus, that's what? Plus. So we have 17 plus 1, that's what? 18. So the electron number is now 18. So all the numbers, proton, electron, neutron, are 17, 18, 18 respectively. They are all very easy. Okay, so with all these, let's go into other aspects of which questions can be asked on this topic. Okay guys, let's get into this other practice question, which is in the nucleus MO9642, what is the nuclear number? This question is very easy. Remember, I said that for we to get our nuclear number, it is same as mass number or atomic number. So nuclear number is same as the value here. And what's the value here that is there? That's A, and this should be 96. So the point here is this: the nuclear number, what the nuclear number here, you don't have to solve. Nuclear number is same as mass number or atomic mass. So the answer is what? 96. So very easy. Okay, so you can see how questions like this are being tackled without stress. They are all very easy. Okay guys, let's get into the last practice question in this video lesson. So if you haven't yet subscribed, do well to hit the subscribe button and also share these video lessons with your friends. So let's get into this question. The question says, give the symbol of the atom or ion that has these informations. So they are not telling us to try to symbolize, form a symbol for all this information given. Remember, the symbol can be in this format or in this format. That is why they say give the symbol of the atom or ion. So the representation can be an atom or an ion. So how do we know specifically which one is an atom or an ion? Because, you know, for ions, they have a charge. And here, for we to simply just take note of that, remember, when we had a neutral atom, the proton number is equal to the electron number. But when we went further for a charged atom, is the proton number equal to the electron number? No. So let's quickly go to our proton number, electron number. 34 proton, 36 electron. So definitely, this can be a neutral atom. This is an ion. What we have to write is an ion. So you can see how you can first of all deduce it. So if you have options, I now see that all other options, they were neutral. You don't have to solve. The one with the charge in it, okay, will then be the answer because the proton and the electron number were not the same. So let's solve now. So let's just call it X. And proton number, remember proton number is always here. Proton number is what? 34. Okay. And then I say it has what? 45 neutrons. Very easy. You know, we are trying to get this and also get our charge. That's what we are trying to do. So how do we do it? First of all, we have to remember how to get our, because here we are trying to get our atomic mass number or nuclear number. So what do we do? First of all, remember this formula that says neutron number is equal to A minus Z. Remember what A is? Atomic mass or this or that. And Z is this down, which is also called proton number. And did they give us did they give us the neutron number? Yes. You know, this is what we are looking for. A. This is what we are looking for. Making A subject, what are we having? Okay, we then have N. This guy comes here. The sign changed to positive plus Z. So A will now, because what's our N? Neutron number 45 plus what's our Z? Z again is what is down, and what's that? 34. So 45 plus 34, that's 79. A now becomes to 79. So here becomes 79. And since our proton number is not equal to electron number, what then happens? Because you can see here that now how do we know specifically the number of charge we have to write? Remember with the formula we said that electron number equals to proton number minus our charge. So guys, let's quickly make the charge subject of formula. So when it comes here, it becomes positive, and our proton remains, electron coming here becomes negative. Okay, so charge then becomes, what's our proton number? The proton number is 34 minus what's our electron number? The electron number is 36, so we have in minus 2 to be the charge. Do you get? So that's how it works. So we've come to the end of this video lesson. Now, if you find this video lesson helpful, do well to click the subscribe button, share all these video lessons with your friends to help one another. Thanks for watching.